and doing your labs. We're going to go over lesson 1, topic 1B, configuring small office and home office networks. The OSI model involves quite a lot of abstraction. As a practical example, it's worth examining how a basic network is implemented. In this topic, you're going to learn the connection and configuration options for components within a typical small office, home office router, a SOHO. SOHO routers. Networks of different sizes are classified in different ways. I'll highlight this part. A network in a single location is often described as a local area network, a LAN. This definition encompasses many different sizes of networks with widely varying functions and capabilities. It can include both residential networks with a couple of computers and enterprise networks with hundreds of servers and thousands of workstations. Highlight this next paragraph. Small office, home office, SOHO, is a category of LAN with a small number of computing hosts that typically rely on a single integrated appliance for local and internet connectivity. Networks such as internet that are located in different geographic locations and regions, but with shared links, are called wide area networks or WANs. Highlight that part. The intermediary system powering SOHO networks is usually described as a SOHO router because one of its primary functions is to forward traffic between the LAN and the WAN. However, routing is actually just one of its functions we can use in the OSI model to analyze each of these in turn. The physical layer functions. Starting at layer 1, the SOHO router provides the following physical connections. A number of RJ45 ports, as you can see here. Typically 4. These are used to connect to a local cable network. These are usually typically labeled as LAN ports. Radio antennas used to transmit wireless signals. A type of modem that typically cable or digital subscriber line to connect to the internet service provider's network. This is typically labeled as WAN on the port. On the example diagram, the interface is another RJ45 port designed to connect to a fiber to a premises internet service using the same Ethernet technology as the local network. On other SOHO routers, there may be a different type of WAN connection, such as RJ11, an old school phone line, landline, or to connect to a subscriber digital line, or a coaxial, Comcast. Data link layer functions. At layer 2, the SOHO router implements the following functions to make use of the physical layer adapters. Highlight these. Ethernet switch, the RJ45 jacks are connected internally by an Ethernet switch. Wireless access point, the radio antennas implement some version of the Wi-Fi standard. The access point functions as a wireless hub, allowing stations, PC tablets, smartphones, and printers to form a wireless network. The access point is also wired to the Ethernet switch via an internal port. This forms a bridge between the cable and wireless segments, creating a single logical local network. And of course, you guys can see that there. Everything's connected to a single logical network. These are connected via the RJ45, and these are connected via Wi-Fi. At this layer, each host interface is identified by media access control address, a MAC address. Network layer functions. At the layer 3, the network layer, the routing part of the SOHO router, makes forwarding decisions between the local private network and public network, as well as the internet. These zones are distinguished by the internet protocol IP addresses. Highlight that first paragraph I just mentioned. The local network uses private IP address range, such as 192.168.1.0 with a subnet of 24. The SOHO router itself is identified by a address in this range, such as 192.168.1.1 or 192.168.1.254. You guys can see an example there, the network layer, private and public segmentations. Highlight this part. The router runs a dynamic host configuration, DHCP server, to allocate a unique address to each host that connects to it over an Ethernet port or via wireless access point. The addresses are then assigned to clients use the same first three octets as the router's address, 192.168.1. The last octet can be any value from 1 to 254, excluding whichever value is used by the router. And of course, you guys can see that thing. And this is generally a configuration table for a TP-Link router. You can see the information there. Local management, remote management. The SOHO router's WAN interface is allocated a public IP address, say 203.0.113.1, by the Internet Service Provider. When a host on the local network tries to access any valid address outside 192.168.1.0, subnet 24 range, the router forwards that packet over its WAN interface and directs any replies back to the host on the LAN. Transport and application layer and security functions. There is no separate OSI model layer for security. Instead, security issues can arise and solutions are needed at every layer. Network security is essentially a matter of allowing or preventing devices, users, and services from using the network. The WAN interface is the network perimeter. The SOHO router can apply filtering rules to traffic sent between the public and private zones, implementing a firewall. The firewall can be configured to block traffic based on source or IP addresses and also on the type of application. At layer 4, highlight this, each application is identified by a port number, such as 80 for Hypertext Transfer Protocol, HTTP, otherwise known as web traffic, or 25 for Simple Mail Transfer Protocol, SMTP, email traffic. The firewall on the router can be configured with rules specifying behavior for each port. For example, computers on the network might use the server message block SMB protocol to share files. It would not be appropriate for hosts on the internet to be able to access these shared files. So the SMB port would be blocked by default on the WAN interface, but allowed on the LAN interface and the WLAN interfaces. Any host can connect to the RJ45 ports on the back of the router and join the network. The wireless networks is usually protected by an encryption system that requires each station to be configured with a passphrase-based key to join the network. Access to the router's management interface and its configuration settings is protected by administrator account and passphrase. As the router is connected to the internet, it is critical to configure a strong passphrase. The internet. The WAN interface of the router connects the SOHO network to the internet. The public switch telephone network. Highlight this first paragraph. Most SOHO subscriber internet access is facilitated via a public switch telephone network, a PSTN. The SOHO router is described as customer's premise equipment, CPE. More widely, this is any termination and routing equipment placed at the customer's site. Some of this equipment may be owned or leased from the telecommunications company or telco. Some may be owned by the consumer. The CPE is connected via its modem and WAN port to the local hub. This is cabling from a customer's premises and local exchange. The point at which the telco's cabling enters the customer's premises is referred to as a demarcation point, often shortened to DMARC. Internet service providers, otherwise known as ISPs. The major infrastructure of internet consists with high bandwidth trunks connecting internet exchange points, IXPs. Within an IXP data center, the ISP establishes links between their networks using the transit and peering arrangements to carry traffic to and from parts of the internet they do not physically own. There is a tiered hierarchy of ISPs that reflects what extent they depend on transit arrangements with other ISPs. Of course, we have internet standards. Although no single organization owns the internet or its technologies, several organizations are responsible for the development of the internet and agreeing common standards and protocols. IANA, the Internet Assigned Numbers Authority, manages allocation of IP addresses and maintenance on top of level domain space. IANA is currently ran by the Internet Corporation for Assigned Names and Numbers, ICANN. IANA allocates addresses to regional registries, who then allocate them to local registries or ISPs. The regional registries are Asia Pacific, North American and South American, Latin American, and Europe, North Africa, Central Asia, and Middle East. And we deal with ICANN actually quite often. We are able to sell domain names, hosting, cloud hosting, and everything else with a deal directly done through ICANN. So we can buy domains like GoDaddy at wholesale and sell them for less than GoDaddy. If you guys are ever interested in that, just check out the website, itabq.com, and there should be an area where you guys can actually sign up to sell domains, and you can use that as a platform to be able to develop your own applications as well. Internet Engineering Task Force, IETF, focuses on solutions to internet problems and adaptation of new standards, published as requests for comments. Highlight that, RFCs. Some RFCs describe network services or protocols and their implementations, while others summarize policies. An older RFC is never updated. If changes are required, a new RFC is published with a new number. Not all RFCs describe standards. Some are designated informational, while others are experimental. The official repository for RFCs is at rfc-editor.org. The OSI model has a stricter definition of the session, presentation, and application layers that is typical of actual protocols used on networks. The internet model tools uses a simpler 4-layer hierarchy with a link layer representing OSI layers 1 and 2, layer 3 referred to as the internet layer, and transport layer mapping approximately to layers 4 and 5, an application layer corresponding to layers 6 and 7. Hexadecimal notation. To interpret network addresses, you first must understand the concept of base numbering systems. To start with a familiar decimal numbering is also referred to as base 10. Base 10 means that each digit can have one of 10 possible values, 0 through 9. A digit positioned to the left of another has 10 times the value of the digit to the right. For example, the number 255 can be written out as follows: parentheses 2 times 10 times 10 parentheses plus 5 times 10 plus 5. Binary is base 2. So the digit is any given position that can have only the one value of two values, 0 or 1. And each place position is the next power of 2. The binary value of 1111111 can be converted to the decimal value 255 by using the following sum. And you guys see that example there in your book. I'm going to copy and paste it into your chat because that is very long, and that'll take me too long to repeat it to you guys. So as you can see in that formula, it takes 8 binary digits to represent the decimal value up to 255. This number of bits is called a byte or an octet. The 4 decimal numbers in the SOHO router's WAN IP address, 203.0.113.1, are octets. While computers process everything in binary, the values make for very long strings if they have to be written out or entered into configuration dialogues. Hexadecimal notation, or hex, is a convenient way of referring to long sequences of bytes used in some types of network addresses. Hex is base 16, with the possible values of each digit represented by numerals 0 through 9, and the characters A, B, C, D, E, and F. Use the following tables to help convert decimal, binary, and hexadecimal values. So this table here is something that you guys want to save. Take a screenshot because it will help you convert. As you can see from the table, every hex digit lines up with nearly and neatly with 4 binary digits, a nibble. Each byte or octet can be expressed as 2 hex digits. For example, decimal value 255 is FF in hex. This would sometimes be written as 0xFF for clarity. Now we're going to have some videos here that'll also go through some of this information for you guys and clarify it. Enjoy.
In this video, we're going to discuss the OSI model. We interact with the OSI model on a daily basis, whether you realize it or not. Consider Alice. Alice needs to connect to Amazon's web servers in order to purchase her favorite product. When Alice opens her web browser, we can see here that she starts at layer 7 of the OSI model, the application layer, that gives her access to the network and the network's resources. When DNS resolves an FQDN so that the URL can allow us to connect to the web server, that's also happening here at the application layer. When we use encryption, encrypted communications between a client and a web server, that happens here at the presentation layer, or layer 6 of the OSI model. The session needs to be brought up, managed, and maintained. That happens here at layer 5 of the OSI model. Once the session is opened between the client and the destination server, we need to guarantee reliable delivery. That is where TCP, the Transmission Control Protocol, comes in and helps us to segment and sequence our information happening here at the transport layer. We also have to make sure that we can address the data so that it gets to the appropriate destination. Addressing and those routing decisions will happen at the network layer, or layer 3 of the OSI model. Layer 3 allows us to connect to remote networks, but before we send any information to a remote network, we must first send it to our local network. And that's where the data link layer helps to assist us, or layer 2 of the OSI model. This is where we see things like our MAC addresses being present on our data. The last layer is we need to take the data, or in this case the frame at layer 2, and we need to convert it into electromagnetic energy or an optical light source and place it out on the physical media. Now, this data packet will go through many hops from source to destination, and those routers that are actually helping us transport that information are using the OSI model in a couple of layers here as well. So when the router on our local network sends the information to the next router, the receiving router, the recipient router, will then inspect the MAC address in the data packet, finding out if that MAC address is bound for the router's interface, and then process that information. Remember, in the data packet, we have the destination server of the e-commerce website that Alice wants to visit. That is the destination IP address in the packet. So when the router inspects the IP address, it'll realize that it's not bound for the router. So the router will stop processing at the OSI model. It will make a routing decision at layer 3 where to send that information, and then it'll place the appropriate MAC address for the interface for the next hop, moving back down to the data link layer, converting that information back into electrical energy or an optical light source as it makes its way out to the physical medium. Now, once the data reaches the destination network of the web server and is delivered to the web server will inspect the data link layer MAC address to determine whether it is its own MAC address. When it determines that it is, it processes this information and then moves up the OSI model. Next, it needs to determine if the destination IP address in the layer 3 header is its own. And when it finds out that it is, it processes that layer 3 header. Next, the information needs to be reassembled and in the right order. This is where transmission control protocol comes in, helping us reassemble the information in the right order, guaranteeing that it's correct. The session still has to be maintained because the server hasn't processed the information yet. Finally, the encryption is going to be removed at the presentation layer, and the data will be rendered, in this case, typically HTML. The web browser will render that information in the application layer, letting Alice connect to her website and view that information.
Awesome for Alice. Next video, guys.
In this video, we want to demonstrate how to install and configure a router. One of the first things that you need to do is purchase a router that meets your needs. Make sure that it has all of the features in the feature set that you want. The next thing that you're going to want to do is make sure that you have obtained the vendor documentation for that specific router so that you can configure it according to the vendor specification. So for instance here, I'm going to go ahead, I've already downloaded the vendor documentation for the router that we're going to configure here, so I am ready to go with that. Now the next thing that you have to do is you have to connect to some kind of configuration port. It could be a console port on the router. In this case, we're going to go ahead and the router that we're using here, we're going to connect to one of the LAN ports right here on the back of the router itself, and we're going to use that for our management, to connect to the management interface. Now that's the next part. The next step is connecting to the management interface. And again, if it's in a console port on a router, you'll probably see that you'll have a terminal of some sort open in front of you. In this case, what we're going to do is browse to the web administration page, check your vendor's documentation. A lot of times they default, in this case, 192.168.1.1, or you might see 192.168.0.1. It's important that, again, you go with the vendor supplied documentation. Now, once that's done, there's a couple of things that we have to do. One of the first things that we have to do is we have to change the defaults. So in order to do that, I'm going to go ahead and disconnect or uncheck this contribute here. And rather than use the Linksys smart Wi-Fi setup, we're going to go ahead and we're going to do a manual configuration, as you see down here. Now, keep in mind, and we do have to accept the end user license agreement, or the ULA, and then we can choose manual configuration. Now, remember that the interfaces will vary slightly. The steps that you perform, however, will be pretty much the same across the board. Like I said, the interface and the actual specifics to the vendor, they might differ slightly than from what you see here. So once we get logged into the interface, and you'll see it takes a second here because it's disabling the more user-friendly interface, and then it disconnects me and reconnects me into the interface that we can do the more advanced configuration. So we'll let it go ahead and get connected here, and then what we're going to do is we're going to go ahead and log in to this router. So let's go ahead and we will do that. And here we go. We've got our configuration page. Now, I'm not going to log in here. This is actually a cloud-based account, and again, specific to Linksys here. So what I want to do is I want to go into local access. Like I said, this could be different from the vendor that of the product that you're using currently. We're going to go ahead and we're going to enter our router, and in our documentation we see what the router's password is, the default password. In this case, the default password you'll see is going to be admin. Now, because not only do we know through the vendor documentation the router's password, so does everybody else who can obtain that documentation from the vendor website. That's the first thing that we're going to do, is change this router's password. So we'll go ahead and in this case, we're going to go to the connectivity setting. Notice that the router's password here, we're going to go ahead and edit this. And for the purposes of this demonstration, I'm going to go ahead and use the super secret password that we've been using throughout our lab demo or lab environment. However, keep in mind that you're going to want to use a complex password. And then once that's done, we're going to go ahead and choose apply, and it's going to ask us if we want to change the router's password. We're going to go ahead and commit those changes to the router's configuration. Now, the next one is, it could be optional. You might have a way to do this in this router, because remote administration is done through their cloud-based platform. I don't see remote administration directly in this console, and we typically want to disable that. And we also want to make sure that we have secure local administration configuration channels. So that could be setting up SSH so that you can use something like PuTTY to console into the device and make sure that the session is encrypted so nobody can eavesdrop on it. In this case, what we're going to do is we're going to change the administration side here. Notice that by default, HTTP is selected. Sometimes you can disable that. Sometimes you can disable HTTP and select HTTPS. In this case, we can't, but I'm also going to uncheck access via the wireless interface. And again, that is up to you and the specifications of your network. So we'll go ahead and we'll commit those changes. And now that we've secured the local administration channel, the next thing that we might want to do is configure some of the basic settings. For instance, some of the basic settings that you might see in here are, for instance, in your connectivity fields here, some of your internet settings are going to be configuring the WAN interface. And a lot of times by default, we might just have an automatic configuration. It might just be DHCP out to our internet service provider. However, depending on your specific needs, you might be doing something like the point-to-point protocol over Ethernet, PPPoE. Might be something, if you're setting up, for instance, a VPN communication, you might actually be setting an L2TP tunnel. And again, really just contingent on your ISP's configuration settings. I'm going to go ahead and I'm going to leave this alone. We could set the MTU. I'm going to set that automatically here. And then we're going to look at the local network. Remember, DHCP, this is something that maybe you want to allow. A lot of times what you'll have is DHCP might be provided by maybe a server within your network that your clients are communicating to. Maybe you don't want this wireless router, in this case, this router, to be able to send out DHCP leases. If that's the case, you can always disable it. However, you might want to tailor the scope down a little bit. Maybe you don't want 100 users on your network. Maybe you want a little less. Well, that is up to you and how you configure that. Maybe you want to set a static DNS. So we can do that if we need to. So for instance, 8.8, we'll get this 8.8.8, and maybe I want to do maybe an 8.8.4.4, and we can set that. Now, a lot of times what we'll also have too, if we are offering DHCP here, is we might have some printers on our network that maybe we want to set a DHCP reservation that's within this lease process. We can always set the DHCP lease right here. Now, we haven't committed these changes yet, and it's warning me of that, so we'll go ahead and apply those changes. And we'll apply those changes to the router. Keep in mind that sometimes you might see that the router reboots and to actually configure and apply those settings. Sometimes it is really just a soft reset, if you will. It's just the fact that we have to wait in the configuration interface before we can get back to it and continue configuring. Now, the other thing that we might do now that we've looked at our WAN link, we've looked at DHCP, is there might be a potential that we need something like port forwarding. This isn't uncommon where you have a communication coming off of the WAN interface and you want it to be directed specifically to an endpoint. And we can do this as well too. And in order to configure port forwarding, let's go here. It's a little different in this interface than you might see, like I've mentioned here. This is actually in security. And while we're here, it gives us a good chance to just take a second and mention things like ensuring that if the router is your firewall, that you're setting up things like stateful packet inspection here. And you can see it's enabled by default too. And you could set some other internet filters here if you needed to, if that was applicable for your environment. Now, in this case, what we're going to do is we're going to go over the apps and gaming section here. And notice that we can set our dynamic DNS if we want, single port forwarding, an entire range, or we can do port triggering. We're going to go ahead and set up a single port forward. Notice that there's nothing really port forwarding rules. We don't have any in here. I'm going to add a single port forwarding rule. We're going to call this remote desktop protocol. And our external port's going to be 3389, internal port 3389, and we'll use both TCP and UDP on this one. It is a TCP protocol, but I'll just keep it at both, and then we're going to define what the endpoint is that we want to verify, that we want to forward that remote desktop protocol traffic to. So in this case, I'm going to use 192.1 or 192.168.1, and then we will forward it to the appropriate IP address, and then we will save this. And now we have a port forwarding rule, and that is ready to go, and we will hopefully be able to forward that traffic as it comes in off the WAN link to the appropriate destination that we see here in the rule, to the appropriate computer within the LAN. And we'll go ahead and choose OK to this. The other thing that you're going to want to do too is that if you do have a new firmware update, you're going to want to go ahead and update the firmware. And there's different ways to do this. Keep in mind that if you are updating the firmware, it's important never to interrupt the firmware. And this could take a while to download the file and then update that firmware. But it is important as well that you are on the latest and greatest firmware when it comes to configuring and installing and configuring your routers within your networks.